How you doing, people? I got I got into the port work finally. Okay, I'm gonna explain this as best I can, where that you can see exactly what's being done in every step. This is really the fun part for me. It really is. I'm so looking forward to this. I want to tell you something. I never port on my bench. I have another bench I do it, but I wasn't going to get good lighting or good video because I was in a more confined space. So when I get done with this, I'm just going to have to freaking vacuum, clean, scrub with soap and water. It's kind of a big deal. And the one thing after you've done your port work, even when you put it back on, your cylinder back on, to check your numbers to see where you're at, take that darn thing near a sink with some drawn dish liquid or Tide soap and hot water, and take a nylon brush or an old toothbrush or something, and you scrub and you rinse. You want to get all of the debris out of this. Now, yeah, that sounds time consuming. Trust me, you're not going to lock a bearing up. You want to see what locks the bearing up? See that little stuff on my finger? One particle of that. That's it. If that gets in your saw and it sticks to a bearing, and it will, you might get lucky, but I doubt it. You just ruined a bearing. So you're doing all this work for nothing. Okay, let's get right into it. I'm going to show you the type of tools I prefer. You're going to laugh. Yeah, I got a nice little angle grinder that works pretty good. It's getting tired. I'm going to have to get a new one. I just use a Dremel for the majority of it to save my little grinder, my angle grinder, okay? I use that ball bit. If you can see that, that's got coarse teeth, okay? That's one I really like for doing inside them transfers. I'll show you how to do that. I like a nice straight cutter here. Now what happens is you'll get them that are tapered. The reason I don't use them is because it's spinning much faster out here, right here, than it is here, as far as is in the rotation of the surface inches. So you'll get aluminum buildup. Use a straight one, find that sweet spot. If you turn your RPMs of your tool too high, you'll get aluminum buildup. If it's too low, it'll chatter. Okay, so find that sweet spot. Okay? Now, when you're porting, I'm going to show you, I'm not going to turn this on because you'll never hear a word I say, but let's just say that the one thing that I do is see these corners on these pistons. When they're like that, I make sure that my intake and exhaust are going to be closed if I cut that corner off. Round that. You get stress risers right in here in this area here. If you don't take that off, just blend that round, and then take a stone or something and make this nice and smooth here on this edge. Them corners, believe it or not, will actually make a mark if you get sawdust or debris in them. Them little corners right there will. So I take them off. Okay. So now let's get right into this. In the direction of your rotation, you want your tool to spin upwards like this. So only work that direction. So you will be moving your tool like this in nice, easy strokes. Okay. Let it get a minute to cut. You'll cut just as smooth as glass when you do that. Okay. And with these little burrs, go ahead and do yourself a favor and make a nice little thin cuts, and then move a little, and just keep making thin cuts. You know, you're doing just that right there, and don't block the air coming out of these. If you grab it like this, number one, you don't have any damn control, and the tool doesn't cool. Hold it just like that. Yep, just like that. That'll help you all in all kinds of ways. Okay, I'm going to jump right into this. The first thing you're going to do, and you're going to look at this and say, oh my God, I wouldn't dare do that. Yeah, you do. Okay, you see this whole, now this whole area right here, I'm going to cut that off to level or just below or just above. It depends on what I'm doing with the saw. If I'm not going aggressive on my ports because I want to keep my velocity quite high and I have a smaller bore, I'll leave that up a little bit. But this is a big bore, so I dropped it just slightly under this level. Okay, and you'll see that why. Now this is in the Husqvarna 70cc saw, 75cc. Okay, the 390s never had this. Okay, they didn't have that in there. Okay, okay, there it is. It's cut off. See the difference? Kind of scary in it. Here's why. This is the inside of your crankcase. Alright? You see that lip right there? Runs across there. The air has to go and flow up this channel into your transfers. Okay? You can do that 100 times off camera. The minute you got a camera, you can't do it. Okay. You see that small opening right there? That's what air can get into. So if you got the windage of the crank you're dealing with, and you're trying to get that air up that little opening from that shelf I showed you to that transfer. They did this deliberately. They held the saw at 5.5 horse. We want more than that, don't we? All right, here's the deal. You're gonna love it. Can you tell the difference? Right here is that shelf. Right there. You notice you can even see up the transfers? If I can see up that, air's going up. I'm plain and simple. It's coming off there and it's flying up them. Okay? That's why you take that off. I know it's an oh God moment. You're going to be shaking in your boots first time you do it because you think, well, just because it worked for him, don't mean it's going to work for me. Oh, yeah, well. Okay, here's another thing. EPA saws. We talked about that lately. The 371 was a pre-runner. It was, for all intensive purpose, met EPA standards of the time. Husqvarna knew where this was headed. They got ahead of the game a few years ahead of time, just like they should. Okay, here's what you got going on. See, right here, this shelf. See that? That makes a much smaller transfer. This is actually your primary, and this is your secondary. Okay, look at the bottom one. Can you see that good? That's gone. Can you see both of them at the same time? That's gone. See that great big piece in there? That's for structural support, so be careful. See that? It's not a knife edge, break the edge. But you use this as a tool because if you look, that port right there lines up pretty straight with that, right? Okay, we're trying to encourage the air and fuel mixture to hit just above the intake. So we got to make that turn, okay? Now, you see where this one is? And see the offset we got right there? And I did the same thing here. And see how I cut this at an angle? I took some off of this end here and this end here. It's much better than this right here. Okay, now what that's going to do is turn that, instead of that air going straight into the piston, see that's about the angle? On this one right here, it's going at an angle. And it's going to hit just above that intake right there. That wall right there. That's where that's going to hit. Okay, now you get the idea there. Now, I raise these transfers in this. I normally see that I can drop them down to within 10 or 15 thousandths of the top of the piston, flows across the top of the piston, and so forth. In this one, the transfers are being interfered slightly at bottom dead center with the piston. And I got a workaround for that, but I'm not going to tell you about that right now, but you'll be able to guess when I show you the next part. All right. Now, what I did was I calculated, which you learned on the previous video, how much I could go safely. Okay. I raised them 6 degrees. If you watch the last video, you can tell me how many thousandths that is. Leave it in the comment section. I want to see how many of you got it. I think you all did, actually. Okay, so that's what you're looking for when you're doing your transfers, all right? Now, I told you that I was going to make a saw that was more torquey, but still had good RPMs. That's a pretty good size transfer. Really, it really is. If you would see that stock before I cut them edges down right here and here, you wouldn't believe how much difference that is. This still ain't as far as you can go. It's all I'm going to go on this saw because I don't need any more than that. I want my velocity to stay high coming out of the transfers right there into the cylinder. Big here, small here. You get a garden hose effect. It works like a tunnel ram, okay? You got it? Anybody's ever played with a car and put a tunnel ram on it or seen a buddy do it, they work. That's what it works like. Okay, so you just figured out how to build a tunnel ram for your saw. Love it. Okay, I told you in the previous video, I was at 104 degrees. My blowdown, that's where the exhaust starts out. Okay, I went part of that by raising my roof. If you notice, that roof ain't straight across, it's rounded. Do that. That way you won't hang a ring. All right? Now here's the fun part with this one. I'm going to get from 104 to 98 degrees. I did part of it in my cylinder. I explained why we do that. This is an X-Torque piston. Ignore it. They're junk. I mean, I love them. I'm going to cut at this angle on the exhaust side from about right here to right here. I'm going to cut just a little bevel. Only go a quarter to a third from your ringland to the top if you got a quality piston. Don't go very far, okay? Because if you go much more than that right there, you're going to compromise that ringland. Because when that piston goes down, first it's under compression, then the ring pushes up. Don't break that off, okay? Anyway, that's how I'm going to get the rest of it. Okay, so we got that kind of covered. I've still got stone work to do, but if this was real smooth, you wouldn't be able to see nothing but glass. I don't make them glass. I'll tell you why. You get carbon buildup here so fast it's ridiculous, and you can spend 10 hours making this so shiny it'll depress you. You know, 2 hours of running and it's got carbon. The intake side, okay? I encourage a little shelf right here, all right, to force the air down into the crankcase. If you can see in there good enough, my bottom is getting fairly flat. You probably ain't going to see very good. But on my bottom, I cut in that corner on each side to get that fairly flat. And I've already gained about 18 thousandths by taking the base gasket out, all right? So my floor of that went down 18 thousandths. I want 20. So by the time I clean up, that's good. Don't exceed 50. Just don't. I don't care what your measurements are. If you stay, when you do the opening, closing, the rotation, like I showed you, don't get real carried away here, because if that stays open too long, that air just rushes right back through that carburetor, and if your air cleaner's off, you see it spitting right out. It's not going the right direction. I want it to go out here. All right? So we got that. Okay. I think we're pretty well covered in that phase of that. Now, when you do a base gasket delete, I want to show you this. Go to a motorcycle shop and ask them for a tube of their assembly silicone. That don't leak. It holds great. if you think your intake's going to leak, you put this little dab, I mean a thin skin of it between your carburetor and your intake. If you glob it right on there, it ain't nothing but a mess. Let me show you something. I'll show you how much. You can use this tool. I've used it. I did a couple years ago on a test saw. I ran out of the good stuff that I buy at a motorcycle shop. High temp red. It works. It just plain works. I don't like it as good, but for this, I found out you can see the red easier. A little dab on your finger, and you're painting that on. Okay? All you're doing is just getting the lightest little skin. See how little is on there? See that? It's just thin. That's all you want. You don't want that going down there and blocking your transfers. I mean, as thin as you can get it, rub it right in there. That's all you do. And when you put that on, that sucker ain't leaking. All right? I'm not telling you that you need to do a base gasket to leak. And there's times I don't. It depends on what level saw I want. Okay? Here's another thing is, don't try getting all excited and busting these things apart. Get yourself one of these. It's a case splitter tool. All right? All it does, when your crank's in there, it goes in there, grabs a hold of, pushes on the end of your crank. You just twist that end, and that'll pull that right off. It does it on both sides. And I'm going to tell you another thing, and you're wasting your time if you don't do this. That's for spinning off your flywheel. Little, that's what works. This is your seal installation tool right here. This is all Husqvarna parts. This stuff is cheap. It really is, compared to busting saws all the heck. Here's your tools. That screws on the flywheel end of the crank. This nut goes up here. And you'll use a wrench on the two. It pushes your crank out safe. The one with the little hole, that screws onto your clutch side. This nut goes here. You just replace this. I'm going to tell you, you're going to save yourself so much grief. When you pull that crank in, you'll feel that kind of come up tight. Stop. Get your other side in. Look down inside and see if your crank's centered. You can measure that if you want to with some feeler gauges. Don't be afraid to switch tools, pull it back a bit, measure, or eyeball it. You want that crank centered as much as you can, so it's put an even load on your wrist pin. All right? You can do this without these tools. I'm going to tell you what, you break one case or bend up the freaking crank in any way by hammering on it, you're going to hate yourself. It's far much more money than what the tools cost. Every series saw you build, do that. All right? Okay, I hope this video was good and clear for you. This is the fun part. Now I'm going to finish my port job. I'm going to put this sucker together, and we're going to make another video.